Guten Morgen, I'm Adrienne Tacke, and I am a Senior Developer Advocate for MongoDB. And today I'd like to talk to you about multi-cloud magic, or in other words, how to leverage multi-cloud data clusters in the real world. Just a quick note, I will be in the Discord as well as answering any questions that you may have, so please feel free to ask any in the YouTube chat, or if we miss any or if you think of something afterwards, I will be in the Discord, so you can find me with my session name, MultiCloud Magic, or by my name, Adrienne Tacke. So let's begin. So in this journey for multi-cloud magic, I want to take you through several areas. I want to first answer and set the tone. What is multi-cloud? Because it's a word that's being thrown around. It's somewhat new. It's kind of the buzzword of the quarter per se. And I want to just make sure we're all on the same page of what we mean by multi-cloud. We'll follow by what is probably your next question, which is, do we really need a multi-cloud option? And is this something that is just going to pass away and be another fad? And then after answering that, we'll go into some actual real-world scenarios where multi-cloud clusters are being used today. And then finally, we'll see how easy it is to set up a multi-cloud cluster of your own. So, what is multi-cloud? At the simplest explanation of what multi-cloud is, and for the purposes of what we're going to talk about, multi-cloud is just any single architecture that uses two or more cloud providers. So you may have heard of the single cloud architecture, where we all kind of migrated from an on-premises data center maybe to migrating to the cloud. And then we have something like a hybrid. And I know even these terms are somewhat debated upon among different companies and different teams. But in this case, hybrid would mean just any public or private cloud, but it would still usually be on the same cloud provider, meaning one of the big three, so Azure, Google Cloud, or AWS. But no, in this case, we're talking about multi-cloud, and again, it's just using any one or two or more of the big three cloud providers in a single architecture. So it could be a single application making use of two or more of these cloud providers, or it could even be two or more of public and private. And that's exactly what it is. It's a mixture, right? It's a mixture, and it could also include public and private from multiple clouds. But the name says it itself. It's multi-cloud. And that's really the only basis that we need to set here. That's fairly simple to understand. We're dealing with mostly the three big providers, cloud providers here. And so the next question that comes up is, okay, so we know what multi-cloud means or what it could mean, but do we really need one? Why is this something that we're even discussing today? Well, let me tell you a story of the past 2 years. In June of 2019, there was a very big outage, and this outage happened to knock out a very large portion of Google Cloud. What happened there was, there should have been a routine configuration change. It was a maintenance event that is normal for Google to do. And what happened was that one that caused this outage, what it intended to do was that the servers that it needed to apply this maintenance event on was only intended for one geographic region. And when that happens, what Google does is it will routinely reroute any jobs that the servers are currently running, the one that they're about to apply the maintenance event to. They're going to reroute it to other machines because they're about to do this maintenance event. But because of a cascading combination of some misconfigurations and a software bug, this led to an automation software descheduling problem, and it happened in multiple locations. So if you want to think about this as the easiest way to kind of understand why this outage occurred is if you think of Google's traffic or network usage as traffic running through some tunnels where they used to have maybe 6 or 7 or 8 tunnels, it effectively went down to about 2 tunnels and became extremely bottlenecked. And so the result of that was an internet-wide gridlock. And that was the really big outage of June 2019. And we call it Wired Magazine called it the catch-22 that broke the internet, because it knocked out huge portions of what they needed to actually fix the problem. But it wasn't just Google. There was also an AWS outage in October of 2019. In this particular case, as explained by the retrospective from AWS, they said, this event was caused by a failure of our data center control system, which is used to control and optimize the various cooling systems used in our data centers. So what happened was they had some control systems that used some third-party code, and this third-party code was what allowed it to communicate with a lot of the third-party devices in their centers, the fans, the chillers, the temperature sensors. So because of a bug in one of those third-party control system logic pieces of software, this resulted in pretty much a bunch of interactions that were happening. It's excessive interactions. And this resulted in the control system being completely unresponsive. So what ended up happening was racks of servers started to overheat, and that bug pretty much caused multiple redundant cooling systems to fail in parts of the affected availability zones. And so that is what caused the outage for AWS. And on, right? Google had another huge one in March of 2020 where there was a significant router failure in a data center in Atlanta. And Azure also suffered an outage themselves. When this pandemic hit, right around, April, March of last year, we really saw it being pushed to its limits when everyone started to go work from home, and all of the shortages started to really show through, specifically in Europe. But just as an example of how much unexpected traffic this pandemic caused, because of so many people going to work from home, they shared some stats from what that generated. A sample was the Teams usage, Microsoft Teams. What they ended up seeing was something around 44 million daily users, and that generated over 900 million meeting and calling minutes on Teams in a single week. So if you think about scale, if you think about, you think about the service level agreements that we kind of keep to heart and think that gives us some sort of peace of mind, it's scenarios like this show us that it's not necessarily the best place to always think that they will be able to handle any kind of unexpected traffic like this, even if they are one of the big three, even if they are such a massive cloud provider, that this one, Azure themselves, are not immune to issues like this. And the pandemic really showed us the limits of what our public cloud providers can give us. So again, on and on, they suffered another infrastructure bottleneck in APAC region. And then the most recent one that was fairly large was the AWS outage due to the Kinesis data streams. So if we take a look at the last few years, we see that there have been outages. And it's, we're not naive. We know that every now and then something like this might occur. We know that it's not always perfect. But the better thing to see in this picture and in this timeline is that there is no cloud that is spared from an outage. And so this is becoming more and more of an issue for more companies as they start to migrate to the cloud, as they start to refactor some of their applications and want to future-proof themselves, or if they're starting to consider, maybe they're having problems with the actual cloud provider they initially chose, and now they're suffering from some vendor lock-in. So that's what we've seen, as consumers of this, as just ordinary people. Even if we weren't developers or anyone who deals with this, we see for ourselves the causes of these outages and how that affects us as a consumer. But then there are the other scenarios to think about. So in June of 2020, there was this think tank that happened, and they brought around 30 IT leaders to discuss what is going to be around the multi-cloud agenda. Namely, what are the problems that they're going to see? What are the possibilities that multi-cloud could unlock for their organizations? And a lot of these executives are from some pretty large enterprises where some of these scenarios could be tested. So people from Dell, from Visa, from MetLife, all these places. And most of these CIOs pretty much said it's not a matter of if, it's a matter of when. Multi-cloud is definitely on the horizon, if not already in motion to move to a multi-cloud architecture, but at least in the future it is working to go there because they want to be. And so there are two very specific quotes from certain people who participated in this think tank that I think capture the essence of why we need multi-cloud pretty well. And the first one is Gregory Scherer, who's a VP of Business Platform Technology from Fiserv, which is an American multinational Fortune 500 company, so they provide financial services. He says the main driver is what our clients are asking for. We have banks that are on Azure or who have an Azure preference. We have banks who are on AWS or have an AWS preference, and Google Cloud, and on and on. We don't really get to choose. And this is something that is so close to home for a lot of the people that we have worked with and a lot of customers that we've worked with that I'll talk about in a bit, that says sometimes you're in a business where you don't get to dictate where your customers hold their data or where they choose to do their business on a cloud provider. And this is a very big reason for why multi-cloud is becoming more and more prevalent and more reasonable for these types of organizations to choose and move towards. The next one is, it's not just the organization. So this quote also speaks to the developers who now have to accommodate this new strategy, right? So Mohan Pucho is a vice president of architecture and digital strategy at Aeon, which is, again, another professional services firm that sells all kinds of financial risk mitigation products. And he says, we have to be native AWS because of their advanced capabilities in analytics. And we have to be in Azure because, frankly, developers love that ecosystem. And productive developers are probably the best thing. So it's not just from the top down that we're getting this kind of directive or are seeing it on the horizon or being told that this is what we need to use. What we've seen is that as we start to create these massive systems and these distributed systems, we find that sometimes there are tools that are better on other cloud providers that we as developers usually want to use the best tool for the job. And sometimes we want to make use of that, even if it's not on the primary cloud that we are already on, or we want to try something new or need to add something in to our existing application that may benefit from a service that is from another cloud provider. So keeping these scenarios in mind and keeping in line that we know that outages occur, we know that no cloud providers are immune from any outage. There's always going to be something there. And understanding that multi-cloud is starting to become more and more a real solution to some of these problems, I'd like to talk to you today about some that are actually being used right now. So I work for MongoDB, of course, but I want to talk to you about how the data specifically and how these solutions use the multi-cloud strategy in the sense that they're able to move their data very flexibly and how that is a key part in this multi-cloud strategy for these customers. So we'll start with one that is very, very common, and this is usually the using the geographic regions that are available to us and complying with certain requirements. So for this particular one, the country of Canada, they set out a strategic IT plan every few years or so, and one of the things that they set is this direction for electronic data residency. So what this means is that for any government entities and any sensitive electronic data that those entities keep, they consider it based on classifications, they need to be stored within a Government of Canada approved computing facility, and they have to be located within the geographic boundaries of Canada. Now, there are a few exceptions. So if there's some sort of consulate or some kind of diplomatic or consular mission that's outside of the geographic regions, those are okay too, to store the data there. But for the most part, they have to stay within the region of Canada. And to further go through this, there are a few provinces that go a little bit further. So that was kind of the overarching for all of Canada kind of directive for this direction of electronic data residency. But for the British Columbia and Nova Scotia provinces, they ask that all of their data from all of their entities as well, like schools and healthcare and all that stuff, they also have to remain within Canada. But Ontario specifically, they only mandate that healthcare data or health records need to stay within. And so when you consider these types of situations and these provinces and these scenarios, what happens is all of their data is most likely going to be stored in AWS Montreal. And with currently, and the last time I checked, AWS has 32% of the cloud market share, and this is the actual region that is there that they're going to be using. And the customer that I'm about to be talking about pretty much had their data in there. So it's not far-fetched to think that their data was stored here. And that's exactly what happened. But imagine a scenario where AWS Montreal goes down. It's not unheard of. We have seen in the timeline that I've brought to you that outages do occur, and they happen to every single cloud. And so what happens is if AWS Montreal goes down and your application happens to be running on it, well, if you don't have a good failover plan, or if you don't have any kind of high availability or fault tolerance built in, and you are solely on a single cloud and on AWS Montreal, well, your application goes down too. And for this particular customer, they were an emergency services client, or they were the emergency services industry. And for that kind of application, you can't, we complain about applications going down, but in this scenario, that's just unacceptable. That's the last kind of industry and type of application that you would want anything to go down. And it doesn't help that that most recent outage with the Kinesis data streams on AWS, it didn't help and make them feel confident either that this was not going to happen again. And we all know that every time an application is down, that almost always translates to either a loss in brand reputation because, your application is down, your users can't access it, and it also somewhat translates to financial loss, either because you lose your users or something more stronger complication of being down is you lose data or something like that. So in this situation, the way this was solved was, first, they took advantage of the only other Montreal node that was available, and that happened to be GCP. GCP has a node in Montreal. But because it's not just the cloud, it's also the region that they were afraid of, they also added 2 additional nodes for extra fault tolerance. In this case, they took advantage of Azure's 2 other regions, one in Canada Central, which is in Toronto, and another in Quebec, which is the Azure Canada East region. And so now in this scenario, what happens is, let's say AWS Montreal goes down, well, that's no problem. They can fail over, or they can have it go over and use the GCP Montreal node. But now if for whatever reason Montreal fully goes out, then Azure Canada Central and or the Azure regions, I should say, can take over for this. So now they're not only protected against a cloud provider specific outage, but also a regional outage. And so that's a very, very common use case that is why multi-cloud is being used. We'll see another one that's fairly similar here, and that deals with Australia. So they have a similar kind of legislation called the My Health Records Act of 2012, and it's the same thing. They have a requirement to not hold or take records outside of Australia. So if you take a look at what the landscape looks like there for their regions, if you are to hold some data there, and you are a health company or health records processing company, Sydney is kind of your only bet there. So whether you use AWS or GCP, it's most likely going to be in Sydney. But again, you are prone to having not just a cloud provider outage if you're only on one, but also regional outage. So in this case, Azure comes to the rescue again, because the only other location that is available is in Melbourne, and that's the Australia Southeast region. And going further, when they saw that there are many, many clients who also needed in-country disaster recovery, they have 2 other regions that they have opened up in Canberra, and it's used specifically for those compliance requirements. So again, this is just another example of we're taking advantage of the regions that are available to us for whatever compliance reasons you may need, whether that is simply to be more available and to have a stronger and more robust plan if you do suffer an outage on one of your main cloud providers, or if you have to follow these kinds of compliance requirements, like keeping your data in a specific region. And just in case you wanted to know, Azure does also have a region in Sydney. So those are kind of the dipping your toe in the water, feeling it out, and most scenarios that we see today that use the multi-cloud strategy employ this. It's simply to gain higher availability. But there's a few other scenarios, some other pioneers, I should say, of where they're trying to make use of this in slightly different ways. So this next scenario I'll talk about is a company that wanted to add a new feature to their application, and we'll see how they used a multi-cloud strategy to achieve this. So this company was running an application, an internal help desk type of application, and their main production workloads were on AWS. However, they wanted to add this recommendation feature into their application. And after they, spoke with their developers, and their developers took some time to research and see what tools were available, I say naturally, but I think GCP has a fairly good hold on anything that is related to artificial intelligence or machine learning. And that's kind of the same conclusion that these developers came to as well. They specifically wanted to use a tool called AutoML, natural language, which uses machine learning to reveal the structure and meaning of text. So they wanted to integrate this now into their application. So of course, the next question you're thinking is, well, in order for this to happen, in order for this to work, we need to feed that data into the AutoML, into that analytics application that's going to be using AutoML somehow. So how do we do that? I'm sure you're thinking of a couple scenarios that may have been done before, and you're probably right, because they have probably gone through those scenarios as well initially. So the first way, and the one common way that we've usually solved this kind of problem, is we write more code. We write custom code in this case, and we write some custom scripts. We pretty much build a unique pipeline to migrate this data or send this data over to the AutoML powered application, analytics application. But as most of us know, this involves a lot of time if you don't have a large team, or if you don't have a team that, can dedicate that time to writing something so purpose-built. And that's also another thing, is whenever you do something this custom and this very specific way, it's not easy to maintain. Anything that's so purpose-built for one thing is always difficult. It costs extra time, extra testing, extra effort to maintain if it's this unique. And even then, when we know this and we say, oh, we're developers, we like to automate the pain away, right? So even if we try to do that in this scenario, which they did try to do with something like Kafka, which can stream updates from one source to another, it was still a little bit too much for them to maintain. It was still another service that somebody needed to worry about, and they'd rather not have that. So what's the next option? Well, another one is for the customer to take snapshots. This is another fairly common way to solve this problem that has been done before. And that's just exactly what it sounds like, right? They take snapshots of their current production data, and then they restore it onto the other database where the analytics application can use it, where it can be analyzed. But again, same kinds of issues where it's another thing to maintain, it's also costly to maintain, but the bigger issue here was that the analysts that they did have were usually working with stale data in this scenario. So whenever this snapshot would restore, they were always working with batches of whatever was restored. So they're always working, and they're always a little bit behind, and they did not like that either. They're always constantly waiting for new data to be uploaded. So in this particular scenario, what did help them was something like a multi-cloud cluster. So this customer, just to preface and to be transparent, they were already using MongoDB Atlas to run their workloads on AWS. It was their databases were hosted on AWS. But now, if they opted to configure and change their cluster to a multi-cloud cluster, what this unlocks for them is that now this cloud database that they're using, where they're storing their data, is now using the same underlying foundation of MongoDB Atlas. And what this means is that now they can take advantage of the different kinds of nodes that we have, and they can also take advantage of separating their operational workloads, aka their production workloads that have been running on AWS, and they can separate it from their analytical workloads, which is the new thing that they needed to move data into Google Cloud for. So what ended up happening here is that they ended up choosing to add another node, but they chose specifically a read-only analytics node. And they added this node as part of their multi-cloud cluster in MongoDB Atlas. And what this type of node does is it is made specifically for analytics workloads, meaning that any of the production traffic that they see on AWS is completely isolated from the data that is being used on GCP. So their GCP node is a read-only analytics node, and any queries that are made against this for analytics or for feeding into the analytics application are solely isolated to that specific node. And then all the other electable nodes, aka the ones that are able to participate in elections, they are left alone as well. They remain on AWS, and they can continue servicing their production workloads while still being on AWS. So that is one scenario. This next scenario, I will say, is very experimental. It's in works, and let's just say they're still trying to get this right, because there's obviously a lot of issues. And as I talk about it, you'll probably think of one or two scenarios or reasons why this is still not as easy as it sounds. So I'm not promising that this is something you can do right away. It's just something that is being tried right now to see if they can fully take advantage of a multi-cloud situation with multi-cloud clusters. So the holy grail that this next customer wanted to do was to do something called what they call cloud arbitrage. And that's basically, they wanted to have some workloads that were able to be, be done in parallel. But to go further, they wanted to take advantage of pricing. And so let's say, as they build this thing, they find that Azure has the best pricing for their particular workloads. They want to be able to burst that over and send that workload over to Azure. But as things change and as pricing change, let's say AWS also goes down or meets some sort of cost threshold that they accept for these workloads, they'd also like to be able to burst some workloads over there and onward. As the prices fluctuate for the cloud providers, they also want to move their workloads to the places that they can take advantage of that lower pricing. And so this is a very idealistic form. The problems that this customer has been seeing with trying to do that is, number one, even though you try to make the workloads as agnostic as possible, every cloud provider themselves is a little bit different, right? You can't just take one particular workload and, say do it over here or do it over there. There are specific configurations for each cloud that need to be done. And even with taking down this barrier of having the data readily available on all three, which is why they used a multi-cloud cluster in this case, it still has a lot of kinks to work out with respect to configuring it per cloud provider. So I'll definitely update you. Follow me on Twitter if I find out that they find a way to get around this problem. But that is one way that that they are experimenting with, and would be, again, the holy grail is what they called it, if they were able to take advantage of it in this way. Now, similarly to this, this is used for a lot, or why a multi-cloud strategy is very appealing to very many companies. One in particular, it's a major auto manufacturing company. What they did here was they had a bunch of workloads running in AWS. And what they did was they spoke to both AWS and Azure in tandem. They were doing some negotiations with their particular workloads. And they are super, super focused on cost optimization. So wherever they got the best price, they wanted to be able to just switch just like that. They wanted to enable their engineers to say, if they were able to get this particular price, that they can just move wherever they needed to. They wanted to have that kind of negotiation power. And so this is less on the technical side, but it is still very much a reality when it comes to the directives that come about, and why we sometimes hear, okay, now we need to be multi-cloud, and this is one of the reasons why. So this becomes possible if they say we need to migrate all of our applications over to Azure tomorrow. This is possible, again, if you were using something like multi-cloud clusters. So again, caveat, this is not some magic thing where if you put your data in MongoDB Atlas, this is going to be available to you. Of course not. The reality is you obviously have to architect your application in a way that makes it able to take advantage of this, where the only piece that you need is the flexibility of the data. So I just want to put that caveat out there. I'm not saying create a multi-cloud cluster and all your problems will go away. That's not the case. But, in this scenario, they did have their applications architected in a way where the only problem that they did have was the mobility of the data. And so with a multi-cloud cluster, which were all hosted on AWS initially, it is as easy as just running a change provider command. So then what happens is when you change the configuration of your multi-cloud cluster, what happens is you gracefully roll over to the cloud provider, the primary cloud provider, I should say, that you're choosing to now move to. So when you run this command or change it in the Atlas UI, you do slowly roll over to the cloud that you want until you're fully on the next cloud provider that you wish to be on. That's like a smattering of the best of all clouds of what clients want, or what, the top level architect decisions that are being made of why multi-cloud would be used. But as we know, it's not just them. There have to be developers that implement this as well. And so that's something that I want to talk about now, of why multi-cloud is should be exciting, more exciting than just another buzzword. So as developers, kind of alluded to it in a couple of the scenarios, but one of the things that I think we all kind of have in common is we want to use the best tools for the job. And if you ask any developer who works on any kind of system, you'll know that there's definitely preference for some developers, but there's also just some tools that are better than others for specific things. So, a lot of people really like using AWS for their Lambda functions for S3. Anything with artificial intelligence or machine learning, people usually gravitate towards Google Cloud, probably because of all the data that they have to work with. But Azure has some fairly good services too. And then for Azure, as we all know, there's a whole smattering of things that we love about Azure, right? I first got started with Azure by implementing the pipelines for our automating the pipelines using Azure DevOps for the last position I was in. But a lot of us use Azure Active Directory for our authentication. So depending on what kind of application you're building, depending on what your company is using or what you think is best for what you are building, we should be able to take advantage of what tools are best for that particular problem. And in this case, we're getting to this scenario now of it's not just what tools are available in this particular ecosystem, but the larger ecosystem, especially as we're all moving to the cloud. And another thing that we're now also being responsible for is we are responsible for even higher availability and even lower latency. So there is a need for us to, expand and become global and make sure we provide the same experience to our customers everywhere, no matter where they are. It can't be slow somewhere, and we need to be able to service all of the customers that we have as we grow. And as you'll see here, these are, at least at the time of writing this talk, these are around the ready to go, built, not planned or future, but in existence geographic regions that are available today from all of the cloud providers. And as we've seen in the Canadian and Australian examples, sometimes we need to make use of some of the other regions that are available to us depending on our needs. And so being a bit more open-minded and taking away that vendor lock-in and being open to using other cloud providers, even if it is just for availability reasons and not any of the other reasons, that is always something that is beneficial for the application. And lastly, the thing that I think is going to be something that we strive for in the future now, as all of this is changing and evolving, is it's no longer going to be thinking of how to best serve this application on a particular cloud provider. This is going to become more common. We're going to be using different tools off of different cloud providers. And so our next biggest thing that we're going to have to worry about or strive for is to be cloud agnostic. Basically, no matter where the data is, whether it's us choosing our data strategy of where to host our data, or if we're similar to the initial VPs that I talked about, where maybe your type of industry is a place where you don't get to choose. Maybe your customers are the ones that you have to, again, service, and they are choosing where they can hold their data or where they can do business. An example of this is, let's say you're in the e-commerce business, or you want to do business with Walmart. They will not do business with you if you are hosting any of your data or using services from Amazon, AWS, because they are technically direct competitors to Walmart. So that was another example of a customer that when they were future-proofing themselves, they needed to take advantage of that and keep that in mind because they were solely on AWS. So having the ability to give your customers the ability to choose where to host their data is something that's important. Wherever they are, you'll be able to be there too. And finally, the last situation where multi-cloud is becoming more and more prevalent is mergers and acquisitions. So another very common scenario that we see all the time is there is a European company who is acquiring a company, some other company. And for the most part, Europe is fairly Azure leaning. A lot of European companies are fully in Azure. And so when this happens, when you acquire a company, usually they're on AWS, and what happens now is the same thing. You need to perform a cross-cloud migration. So what do we do here? Well, the same options kind of apply to the last scenario I showed you. And of course, there's always an option to do custom scripting, but we already spoke about why that's not always the best case. Now, another option that is available is something called live migration. So again, this particular scenario, this case, they were already using MongoDB Atlas for their database foundation. And what they could use was something called live migration. But even this comes with its own limitations, and it requires some coordination with different people to make sure that this does perform the way that it's expected to. The biggest problem with live migration is that it will, roll over and cut over, but to make sure it properly cut over, someone needs to bounce the connection string once it has fully moved over to Azure. And that's, even though that sounds like something small, that is a big pain for a lot of the customers who do cross-cloud migrations. It's very annoying to deal with. So again, in this particular case, multi-cloud clusters came to the rescue. Because again, all they needed to do was make a configuration change to their cluster to move from an AWS region and make not only a multi-cloud cluster, but make the Azure cloud provider their highest priority, their main provider. And what happens in this scenario, when you do change these cluster settings, it will do so in a graceful manner. So how does it do this? This is obviously a very simplified example of what their architecture looks like, but by default, MongoDB Atlas clusters are a minimum a 3-node replica set. So what would happen is we would start migrating the 2 secondary nodes of your cluster. So we would migrate them over to Azure in this case. We would then elect a new primary. So you'll see now the primary is now one of the Azure nodes that have just been moved over. And then we finally migrate over the last secondary that is remaining. And now you are fully onto the Azure hosted by Azure cluster. And this is all taken care of for you because it's the managed service of MongoDB. But the biggest thing that this solves here is that you don't need to bounce the connection string. And that was one of the biggest annoyances of the previous solution that annoyed a lot of people. And so in this scenario, you don't have to do that anymore. And this makes it a lot nicer to do this kind of cross-cloud migration. So these are the smatterings of real-world multi-cloud clusters that are being used today. And these are very, very common use cases of where multi-cloud is trying to be taken advantage of. So with around 2 minutes to spare, I will show you now how to create a cluster. But before that, I totally blew my thunder. But the key thing to remember here is that something that Brad Lewis said from that CIO think tank, which is if you want to start to have the true portability of applications, obviously the data has to go with the application. And so we're going to go see how easy it is to build a multi-cloud cluster. So you'll see here, if you're familiar with MongoDB Atlas, which is our database as a service offering, you may be familiar with this before, where you would choose the cloud provider, the initial cloud provider that your cluster would be hosted on. But now that multi-cloud clusters have been generally available for a while, we just turn this on, and there is an API for this. It should be either just coming out or should be coming out soon. So that's why I'm showing through the UI right now. And we will set up a very quick multi-cloud cluster here. So I'm based in Las Vegas. It is almost 1 in the morning here, but that's okay. And as you'll see, you'll get a warning here. They want to make sure always an odd number of nodes. That way it ensures reliable elections whenever that has to occur. So I'll choose Azure here because they have a California region. We'll do, We'll do also 2 nodes. And now it's going to be 4 nodes, which we don't want that. We want an odd number. AWS North California, and we'll do 1. So this is called a 2-to-1 node distribution. And this will, this is the minimum that you would need to have both read and write availability guarantees. And as you'll see, these are the read-only nodes that I was talking about from the recommendation feature where they wanted to add AutoML in. You could add it there. Or I'm sorry, this is the one, the analytics nodes. These ones are great for optimizing local reads. And so we would create this cluster, but I already have one created because nobody wants to watch that being done. And you'll see here, this is what you would end up with, right? You'd have a primary here, which is in our preferred region of GCP. And you have your secondary regions as well, both in California and in North California for AWS and Azure. And if you want to have more resources, I actually did write a full, much longer, in-depth tutorial of how to build your own cluster, including what all the different nodes are, what the node distributions are. Find me in Discord. I'll send the link there. And yeah, that's it. Maraming salamat. Thank you so much for taking the time to listen to me. And I've practiced this a lot, so please bear with me. Vielen Dank an alle, die das Global Azure Österreich möglich gemacht haben. Thank you very much. And if there are any questions, let me catch up on the chat here. So we have a question from Victor Gonzalez. That's something like Cast AI, I guess, even though Cast AI is K8 specific. It sounds vaguely familiar. We can follow up on Discord. Yes, that's certainly some, yes, to answer your question, yes, that's what they were trying to do, at least the notion of it with their particular application. But yeah, if you have any other questions, feel free to ask in the comments or find me on Discord. I'm happy to chat more about this. If you still think that this is a fad, I'd love to talk to you further about it.